I'd like to welcome back Koichi Sasada.
Hello, good morning. So, this morning I worked 30 minutes for my healthy let's say the Crown Residence stage, and I googled the Crown Residence Convention Center. So there is a different this Google map points different places. So I can walk 30 minutes this morning. So, it's nice. That's it. Okay. So hi again. So last year I could speak the first RubyConf Philippines about this topic, and after 1 week I got wedding party. This is my first year wedding party anniversary. So this is very impressive, so very important conference for me. So this RubyConf Philippines, very important event. So I'm very happy to stand here again. And thank you so much to accept my proposal. So today, I want to talk about the memory GC improvement report of the Ruby 2.2. So last year, I talked about how to tune the garbage collector, and after that, we want to improve the performance of the garbage collection for the Ruby 2.2. So I want to introduce this improvement. So this is a very short summary of my presentation. So as you can see, Ruby 2.1 improves the throughput of garbage collector, so we can make 2.5 faster compared with Ruby 2.0 and Ruby 2.1. So it is a great improvement, I think. But it is a background. It is not today's topic. So we can reduce the time of the garbage collection. So it shows how much time is consumed by the garbage collection for each garbage collection. So previous Ruby 2.0 or before, so it means that without generational garbage collection, improves the performance. So it means so y-axis is execution time. So before the generational garbage collection implementation, it consumes a huge time, but most of case with generational garbage collection, it only consumes the short time. However, so I mean that most of cases it is faster than the garbage collection, so without garbage collection, generational garbage collection. But there is several peaks. So some cases it is slow. So it means that the garbage collector stops your application. So this is a problem. So we can summarize this with this table. Throughput, so Ruby 2.1 with generational garbage collection, throughput is high, but the maximum pause time is bad, so long. So we need to show the maximum pause time. So to to reduce the maximum pause time, the incremental GC algorithm is well-known algorithm to improve this issue. So we combine the generational garbage collection and incremental garbage collection on the Ruby 2.2, so we can achieve the high throughput and short pause time garbage collection. So this is the achievement of our Ruby 2.2 improvement. So with the generation garbage collection, there is a several peak times. So, but with generation incremental garbage collection, so we achieve the short maximum pause time. So this is a conclusion. So after that, I show you the more technical details, so highly technical. So this is my message. So go back to home and please say your friends. So Ruby 2.2 is great. So if you have any interest about the technical detail, please continue to listen my presentation. If you don't have, so you can Google all the activities. So let me introduce myself. So I am Koichi Sasada, Ruby committer from 2007, and originally virtual machine named Yao, yet the virtual machine developer from the 2004. And I live in Japan. Today I came from Japan. And I'm a member of Heroku. Heroku employees Matsuchi, Yukihiro Matsumoto, and the original author of Ruby is my boss, and our team try to improve the quality of Ruby interpreter. Last year, I borrowed the message from Matsumoto-san. But this year, sorry, I can't bring his message. So our target is Ruby 2.3 and Ruby 3.0, the next version, next minor release and next major release. Last year, Matt published the image of the Ruby 3.0, the big changes. But so we are discussing about these big changes and the small changes for the Ruby 2.3. So last year we released Ruby 2.2. So it is current stable. So I want to introduce something about Ruby 2.2. So Ruby 2.2 has not so big feature changes, but we introduced single key hash literal with quotation. So maybe you can see, you know that you can write a hash literal with this notation. So it means a symbol to the something. But it is dropped. So maybe you know the JSON format. So JSON format, this format shows a string to something, but it is so Ruby different. So it is maybe I think this is drop. So I already wrote a long code. I think that this is string. so please care about that. So with this one, so we can improve some height or something, any characters in symbol. And also, Ruby is able to introduce classes and methods, some useful methods. And also, Ruby is able to introduce internal changes such as removing the obsolete extension APA and hide internal definition of these types. Maybe it is for the C extension writers. And also we improve the performance. So we improve the performance with symbol GC. So symbol GC is very famous. So last year RubyConf Philippines, I show you something about that, but we release with this feature, and we improve the generation garbage collection performance and incremental GC today's topics, and improve the performance of keyword parameters and frozen string readers. So I want to introduce the symbol GC at first. So maybe this is the same example I show you in the RubyConf Philippines last year. So making the 1 million symbols, so integer to string to the symbol. So this creates 1 million symbols, and after that, check the number of symbols. We can see on Ruby 2.1. So there is a huge number of symbols. So about 1 million. So it is not GC. But on Ruby 2.2, sorry, it's not the development version. So we can see that all of the dynamically created symbols are corrected. But so it is what we show. We say in the release note. But after that, there is a trap behind. Ruby 2.0 has a memory legal bug. So actually, we create the symbol object and also corresponding the string object. So symbol has a string representation. So maybe you can see the symbol 2s returns a string, so corresponding strings. So we need to create the symbol object and string object. So we correct the symbol object, but the corresponding strings are not corrected. This is critical bug for this feature. So we solve this issue on the Ruby 2.1. So there is no problem, I think, but there is also problem. So after release of the Ruby 2.1, some people showed us the bug about so this bug ticket. So it is introduced from the Ruby 2.1. So maybe Ruby 2.2 will solve this one. But this bug is only on the end of process. So this is a problem when finalizing the Ruby interpreter. So maybe it has small impact. Also, the Ruby 2.2 introduced faster keyword arguments, so keyword parameters. Ruby 2.0 introduced the keyword parameters, but it was very slow. So compared with the normal method dispatch and the keyword with the keyword arguments, it is 3 times slower. It's too slow. So compared with the normal usual method dispatch, so this is because keyword argument making the hash object and create with these hash objects. But so keyword parameter is very useful. So recently I made a Ruby program, Ruby script, and so I found that so keyword parameter is very nice because we can put any parameters with not in order. So optional argument we need to know the order of parameters, but keyword parameters we don't need to care about the order of parameters. So that's useful, but it is too slow. So Ruby 2.2 introduced the performance of the keyword parameter. So it is 30 times slower on the Ruby 2.1 and Ruby 2.0, but Ruby 2.2 we improve the performance for 40 times faster. So because we so by removing the hash object creation, so so it is compared with the normal dispatch, it is 2 times slower, but maybe it is not so big issue. So please enjoy with the keyword parameters. So that is something about Ruby 2.2. Ruby 2.2 has other good features, so please try it. So back to the garbage collection talks. Ruby is created as Ruby created as 1993. So it has more than 20 years history. But most of the time, so RubyGC is very simple market state garbage collection, and also so recently we improve the performance with latency on 193 and bitmap marking on Ruby 2.0 and generation garbage collection on Ruby 2.1. So this is the basic algorithm of the garbage collection. The name is simple marking and sweep. So mark the reachable of every reachable object. Marking every reachable object. This one. So traversable object we can mark them. And we can think other objects, not traversable objects is unused objects. So we can collect these not marked objects. So this is simple mark and sweep algorithm. It's very easy to understand, I think, but it is too slow. So we introduced the Ruby generational garbage collection from Ruby 2.1. So the concept of generational garbage collection is most objects are young. So most of object is temporary objects. So for example, we made temporary arrays, temporary strings, and so on. So we can collect only for the young objects. So the basic concept is to separate younger generation and old generation, and create object as the younger object and promote object to the old object when the object still alive. So we only correct only for the young generation. We say that it is a minor GC, and garbage collection for the all of objects we say that it is a major GC. So many minor GC and rarely invoked major GC, we can improve the performance, we can improve the throughput of generation so garbage collection times. So this is a figure of how works the generation GC. So there is several younger objects, new objects. So we can mark all of the objects, and after that we mark and we check if they are old objects. After that, second time we can traverse these objects, but these old objects only point to the old objects, so we can not need to mark everything. So we can skip the marking phase for the old objects. So it is why generation GC is found. So there is an assumption for the generation GC. So old objects only can refer to the old objects. So old objects only refer to the old objects. But when there is a difference from the old object to the new object, it is bad. So we need to check the reference creation from the old object to the new object. So when we find such a reference old object to the new object, we remember the old object, this old object, and after that, when the marking phase, we check the references from this old remembered old object to, and we can traverse this new object. So this is why the generation GC works. By the way, this presentation has many characters, so I published this slide after this presentation, so please check it if you want to know the details. So to detect the old to the new object, such reference, we need to insert right barriers. So right barrier, this is keywords to the GC implementation. So if old object, if there is making the the reference from the old object to the new object, then we want to detect such a reference creation. So this reference creation means that writing the reference from this old object to this new object to old objects. So we need to check the right operation. So as Ruby 2.1, before the Ruby 2.1, we don't have any right barriers, so it includes the compatibility issue. So we introduce right barrier unprotected objects. So it is very technical talk. So, but I try to explain this technique. So right barrier unprotected objects. So we can separate the object into the two types. So protected objects and unprotected objects. And we guarantee the right barrier for the right barrier protected objects, but we don't guarantee right barrier protected objects. So with this right barrier unprotected objects, we can make a correct generation garbage collection. So skip something. So introduce several rules. It works. Maybe you are using Ruby 2.2 or Ruby 2.1, and maybe you know it works. So maybe this theory is not it includes any bugs. So if we find the right barrier unprotected object from refer from the old object, we remember that this right barrier unprotected objects and mark every time every minor GC from this object. So it works fine. So with this technique, it reduces the huge time of the garbage collection. So it shows the marking time. So this is the execution time of the GC phase, each GC phase. So marking time is very slow without the generation garbage collection, but with generation garbage collection, it is very slow and very fast. It is micro benchmark, but you can see that so huge marking time reduction. So so marking time is blue one. So without generation garbage collection, it consumes the 1.7 seconds, and but with generation garbage collection, almost 0 seconds. It's too fast. With the RTOC application, so it is not a huge application using the generating the RTOC. So we can see that most of minor GC is very, very fast. So there is a several peaks, so it is their major GC. So major GC is not so fast, but it's only not so many major GC. So there is no problem. So there is several more detailed data that I speak. So this is the time chart of the generation GC. So before the generation GC, so we pause the marking time. So we pause the long marking time and shows divided sweeping time. So it calls a lazy DC introduced from the Ruby 193. But the minor GC is only consumes only small time for the marking time. So this is what mid-generation GC can improve performance. With so on the major GC, so we need to full GC, full objects, garbage collected full GC. Then we need pause long time. So this is a long time examples. So sometimes it is no problem, but for the web application or something less, so the response time is important case. It is problem, I think. So most of requests is faster, but some requests only a few requests it consumes a long time. It will be a problem. So this is what we want to solve on the Ruby 2.2. So generation GC achieves a high throughput, and minor GC stops only a short pause time, and major GC still stops long pause time. So we want to reduce the long pause time on the major GC. So we combine the generation GC and incremental GC. Incremental GC is a very well-known algorithm to reduce this pause time. So this is the start of today's talk. So incremental GC is a very well-known algorithm to divide the marking phase. So basic GC divides the sweeping phase for several phases, several processes, but incremental GC also divides one marking phase to the several marking phases. So we can say the lazy sweep is also incremental GC. So from Ruby 2.2, we can also make marking phase incrementally. So we want to define the three terminology to explain the incremental GC. So white object is not traverse object, and gray objects are marking objects, and the black objects are marked objects. Maybe it is so difficult to understand, so please see this figure. So there is several objects. So at first we color every object for white and gray root object. So root object is only this one. So color this object gray. After that, choose one gray object, this one, and gray the referring objects. So this object refers to these two objects. So gray this and this objects. And after that, so there is no other white object to differ from this black object. Then this gray object. So grab this object and repeat this process. So choose this gray object and gray this gray differing objects and black one and so on. So this phase we can make incrementally. So for example, after this phase we can back to the Ruby process. So do some Ruby program and back to the garbage collection phase and do something. So this is a simple basic concept of incremental GC. So if there is no gray objects, then we can collect the remaining white objects. Incremental GC requires also the right values similar to the general GC. For example, black this gray this object and there is a black object, and running Ruby program. Ruby program can make a reference from this black object to the white object. So such a reference breaks assumption. So black objects only refer to the gray objects. So we need to detect this one and by right variable. So if such a reference black object to the white object, then gray this object, and continue the marking phase. So this is a simple algorithm to make one and to make incremental GC correctly. So this is a well-known GC algorithm, but Ruby MRI doesn't have the perfect right variance. So we also need to consider about the right variant unprotected objects. So after that, so introduce a new rule. So scan all black or right variant unprotected objects at the end of it. So this rule make incremental GC correctly. So let's see this one. So consider that this black object is right variant unprotected object. So there is no right variant from this object. So when the Ruby program making such a white object, we cannot detect such a different creation. So at the end of incremental GC, we do something rescanning the objects from these or every right by unprotected objects. So after the normal incremental GC, after on the last phase, we refer from these unprotected objects. So we can refer all objects correctly. So this is what we do this one. So such a marking phase is at the so we need to solve this marking phase. So it increases the pause time. So it will be a problem of increase the pause time of garbage collection. But I think it is not problem because basically the unprotected object, unprotected object is very small number, and also it is faster or similar time with minor GC. So I think it is no problem. But we need to investigate this. So we need to evaluate on the real Rails application and the pragmatic application. So if you have any measurement or if you have any ideas, so please tell me about that. So there is only a few minutes, so I skip the how to implement this incremental GC, but I wrote a diagram of the control flow of garbage collection, and we introduced several bitmaps for these data structures. So I think it is very interesting. So it is not for Ruby program, but for C programmers. So it is very interesting for so if you have any interest, please read this slide or ask me directly. So measuring this simple Rails application test written by Aaron Patterson. So we can see that there is no peak on the incremental GC. So without the incremental GC, normal generation GC, it has several peaks, so long pause time, but with incremental GC, we don't have any peak times. So it is comparison of the maximum pause time. So without the incremental GC, we consume the 15 milliseconds, but only 4 seconds with incremental GC. So this is what we achieved on the Ruby 2.2. But I want to emphasize this slide. So incremental GC is not a silver bullet. So incremental GC only divides the GC phase, so long pausing GC phase. So incremental GC doesn't include the throughput, total GC time. Only divide the GC phase to the several phases. So if you have any trouble with the garbage collection, please measure something with these methods, or ask me directly. So we can help you to solve your application pause time or application throughput. So I want to introduce several references. So I wrote an article about the incremental garbage collection on the Help Engineering blog on this URL, and also Ruby and Microscope written by the Pat. It's very great book to know the internal. So this is a summary. So we achieved the high throughput and short pause time with combined generation garbage collection and incremental garbage collection on Ruby 2.2. So after that, on Ruby 2.3 or later, we want to introduce another technique to improve performance of GC or other components such as virtual machine or something. So thank you very much.